Good morning, students. I welcome you all for the session 3 of this analysis of indeterminate structure subject. So, in session 2, we have solved one problem. Now, we're going to solve one more problem on this three-hinged arch. The problem is like this. Three-hinged parabolic arch hinged at supports and at crown has a total span of 24 meter and a central rise of 4 meter. It carries a concentrated load of 50 kilonewton at 18 meter from left support and a UDL of 30 kilonewton per meter over the left half portion. Determine bending moment, normal thrust and radial shear at a section 6 meter from left support. So from left support, right, that is from A, we have to find out bending moment, normal thrust and radial shear. So the figure will be like this. This is a three hinged arch hinged at A, B and C. The total span of the arch is 24 meter. Okay, half will be 12 and 12. Okay, then as per the given problem, there is a concentrated load of 50 kilonewton which will be acting at a distance of 18 meter from left support. So from left support A at a distance of 18 meter, there is a point load of 50 kilonewton. Similarly, along with this, there is a UDL of 30 kilonewton per meter over the left half portion. Okay, so for left half portion of the arch, there is a UDL of intensity 30 kilonewton per meter. So this is the diagram. Okay, so now let us solve this problem. As per the problem, first we are going to find out the reactions. As you already know that, so when you want to find out the reactions, we are going to consider the complete arch. So first we will find out the vertical reactions. Okay, we will find out the vertical reactions. Okay, that is VA and VB you will going to find out. So for this vertical reactions, we are going to consider the complete arch and take moment of all these forces about any one support, either A or B, and that is summation M is equal to 0. So let us take a moment of all the forces about A. Okay, taking moment of all the forces about A, support A, that is summation MA is equal to 0. So even you can take moment about B also, no problem. Okay, let us take moment of all these forces about A is equal to 0. So a moment of HA is 0, moment of VA is 0 and moment of HB is 0 because all these will going to pass through point A. Now let us take moment of this UDL and moment of 50 kilonewton and moment of this vertical force VB. Okay, summation MA is equal to 0, and again the sign convention will going to remain same, that is clockwise moment will be positive and anti-clockwise moment will be negative. So for now take the moment of all these forces about A is equal to 0. First I will take this VB with reference to A, this will produce anti-clockwise, that is minus VB into 24. Then I'll take this 50 kilonewton force, moment of this 50 kilonewton force about A, 50 into the perpendicular distance is 18. With reference to A, this 50 will going to produce clockwise, that is plus 50 into 18. Then this UDL. Okay, so first convert this UDL into point load, that is 30 into distance for which it is acting. So 30 into 12. So 30 into 12 becomes what? Point load, right? And the moment of this point load with reference to A will be distance 6. So into 6. So this point load will be in clockwise direction with reference to A. This is also plus. So this should be is equal to 0. That is summation MA is equal to 0. So from this we can find out the reaction VB is equal to 127.5 kilonewton. So the reaction, that is vertical reaction at B, VB is equal to 127.5 kilonewton. Okay, now next another vertical reaction VA. For this we will going to use another equation, summation Fy is equal to 0. summation of all the vertical forces is equal to 0. So how many vertical forces? 1. Then when you convert UDL into point load, that is second, third and fourth. So now again sign convention, upward force is positive, downward force is negative. So plus VA, okay, then minus, this is downward, minus 30 into 12, minus 30 into 12, then minus 50 plus VB, this is equal to 0. So the value of VB is already known, that is 127.5 kilonewton. From this we can find out VA is equal to 282.50, 282.50 kilonewton reaction. So considering the complete arch, we will find out this VB and VA. Next, after finding out this vertical reactions, now we're going to find out horizontal reactions. Horizontal reactions, that is HA and HB. So as you already know that HA and HB are always same. Okay. So we'll find out one reaction and the same will be other reaction. For this, now when you are finding out the horizontal reaction, so you can consider only half portion of the arch. Either you can consider AC portion or BC portion. So let us consider the half portion of the arch, that is BC. Okay, so this is the half portion of the arch. This is B. This will be C. And we know that already the reactions at B, VB is equal to 127.5 kilonewton and this will be HB. Okay, and this half span is 12 meter and the central rise is 4 meter. Okay, and already there is a one more point load is there, that is a 50 kilonewton. 50 kilonewton point load is there and this will be at a distance of 6 meter, means this is also 6 meter. So with this we can find out the horizontal reactions, okay, HA and HB. So again take moment of all the forces about C, okay, that is summation MC is equal to 0 because C is also a hinge. So take moment of all these forces about C and equate it to 0. So again the sign convention remains same, clockwise will be positive, anti-clockwise moment will be negative. So now let us take first VB. So this is with reference to C, this will be anti-clockwise. So minus VB into perpendicular distance is 12 meter. Then HB, okay, this is plus with reference to C, this will going to produce clockwise. So plus HB into perpendicular distance is 4 meter and then with reference to C, this will going to produce clockwise. Again this is plus 50 into 6, okay, 50 into 6. So this is summation MC, this is equal to 0. Okay, so we already found out the VB, that is 127.5 kilonewton. So with this we can find out horizontal reaction HB is equal to 307.5 kilonewton. Okay, so this is the horizontal reaction at B, that is HB. Okay, as we know that similarly, so HA is also the horizontal reaction at A is also nothing but HB, that is 307.5 kilonewton. Okay, or you can write totally HA is equal to HB is equal to H, that is 307.5 kilonewton. So this is what the horizontal reactions HA and HB is equal to H, that is 307.5 kilonewton. Okay, now after finding out the reactions, that is vertical reactions and horizontal reaction, okay, now we'll start with the first quantity what they were asked, bending moment. Okay, bending moment at 6 meter from the left support. Now they were asked, we have to find out the bending moment at point D, which is at a distance of 6 meter. So first is bending moment at 6 meter from left support. Okay, bending moment at 6 meter from left support. Now see, this is what again we're going to draw the diagram. Only 6 meter span we have to consider. This is hinge A. Okay, this is point D. Okay, which is at 6 meter from the left support. This is 6 meter. Okay, and this is the UDL. Okay, this is UDL, which is 30 kilonewton per meter. Okay, this is 6 meter, and this ordinate we don't know. Let us write this as YD, vertical ordinate, and we already found out this reactions. VA is equal to 282.50 kilonewton, and this you can write it as HA or H is equal to 307.5 kilonewton. Okay, so this is what the diagram you have to draw at 6 meter, means at D we have to find out what is the bending moment. Okay, now when you want to calculate the bending moment at D, right, so when you take the moment VA into 6, then H into this YD. So before calculating bending moment at D, let us calculate this vertical ordinate YD. So similarly you can calculate theta also, because that theta will be used when finding out the radial shear and normal thrust. And we know that what is the equation of parabola? Okay, equation of parabola we can write it as YD or Y is equal to 4HX divided by L square into L minus X. This is what we have studied in the first session. This is the equation of parabola. Now here, what is X now? We are finding out the bending moment at a distance at D, which is at distance 6 meter. So X is equal to 6 meter. Total span of the arch is, okay, the 24 meter. Right, so let us find out YD, and we know that tan theta, okay, we know that tan theta is equal to, that is also denoted by dy by dx. Okay, so therefore we can find out YD from this equation. YD is equal to 4h divided by L square. I will take x inside. This is Lx minus x square. Okay, Lx minus x square. Okay, now let us find out dy by dx. So dy by dx, that is differentiate, okay, differentiate this equation with reference to x. So after differentiating we get 4h by L square into, okay, Lx, differentiation of Lx is L minus x square is 2x. Okay, so substitute here 4, okay, h is 4 meter, that is a central rise, divided by total span is 24 square into L is 24 minus 2 into x is 6 meter. Okay, so therefore dy by dx is equal to 0.33. Okay, so dy by dx is nothing but tan theta. So tan theta is equal to 0.33. Therefore theta is equal to 18.43. Okay, so theta is equal to 18.43 degree. Okay, now similarly, now what they've asked, we have to find out the bending moment at point D. So similarly here YD is, first we have to find out the YD. So vertical ordinate YD is equal to 4hx by L square into L minus x. So here 4 into 4 into x is 6 meter divided by 20 square into L is 24 minus 6. So this YD comes out to be 3 meter. Okay, the vertical ordinate YD will be 3 meter. So after finding out this, now we can find out the bending moment. Okay, bending moment at 6 meter from left support. Okay, bending moment at 6 meter from left support, that is at point D. So therefore bending moment at D, that is MD is equal to, okay, now here the sign convention is, okay, for sagging it is positive and for hogging it is negative. Now let us calculate the bending moment at point D. So with reference to this diagram, now bending moment at D is equal to, right, so this is with reference to D, this is clockwise, so VA into 6 meter, then this will be minus hogging, it is minus h into YD, we already found out the YD. Then with reference to this UDL, this is also minus, that is minus 30 into 6 meter is the point load. Okay, and the moment at D is equal to 30 into 6 into 3. Okay, so this is what the bending moment at D. So bending moment at D, MD is equal to plus VA into 6 minus H into YD, okay, minus 30 into 6 into 3. Okay, so this comes out to be bending moment at 6 meter from left support, MD is equal to 232.5 kilonewton meter. This is what the required thing. Moment at D, which is at 6 meter from left support, 232.5 kilonewton meter. So this is the first quantity we have found out. Now the next is the second thing what they have asked in the problem. Okay, that is normal thrust and radial shear at the same point, that is at point D. Okay, second thing is normal thrust. Okay, normal thrust, it is denoted by what? N is equal to, already we know that N is equal to H cos theta plus V sin theta. We already know this equation. Okay, normal thrust at any point on the arch. So here we already know that H and cos theta we know, but before that we will going to find out the V. V is the vertical shear. So vertical shear or just shear force, you can write vertical shear at D, that is V is equal to, vertical shear at D is equal to, now here you can see what is the vertical shear at C. Add all the vertical forces. How many vertical forces here? One is VA and another is 30 into 6. This is down. So this is plus VA and this is minus 30 into 6. Okay, so V is equal to plus VA minus 30 into 6. VA is already known, that is 282.50 minus 180. So shear force at D, V is equal to 102.5 kilonewton. So V is 102.5 kilonewton. So once if you find out V, then substitute this V here. Theta is known, H is known. Now V we have calculated. So let us find out normal thrust N. So normal thrust N is equal to H cos theta plus V sin theta. So H is 307.50 into cos theta is 18.43. Okay, theta is 18.43 plus V 102.5 into sine 18.43. So this normal thrust comes out to be 324 kilonewton. It is a force. Okay, normal thrust means it is a force which is perpendicular to the axis. This is 324 kilonewton. Similarly, we can find out radial shear. This is denoted by Q. Okay, so we know that radial shear Q is equal to, okay, H. In place of cos theta, it is H sin theta, but it is minus here, minus V cos theta. So therefore Q is equal to 307.50 into sine of 18.43 minus V is 102.5 into cos of 18.43. So this comes out to be, okay, minus 0.027 kilonewton. So radial shear at point D is minus 0.027 kilonewton. So the normal thrust is 324 kilonewton. Radial shear is minus 0.027 kilonewton, and already we have find out bending moment. Okay, bending moment at the point D. Okay, we all found out this. Okay, so hope you understood this problem. Okay, if any clarification is there, please feel free to call me at any time. Thank you very much. Hope we will going to meet again in the session 4. Thank you.